All right, as I was saying, because of precession, the Earth wobbles, and that wobble, over the course of thousands upon thousands of years, can be noticed in the sky. All right, so um, that's what they're showing you here, and then actually, by the way, that affects the tilt of the Earth. Um, so that'll affect the weather as well. But this you're talking about the over the this wobble takes 26,000 years to to wobble around once. All right, so it's a very slow process. It's nothing to be too worried about. All right, whoops, I went the wrong way. So it's precession. Over the course of a long time. Da, da, da. Yeah, it will affect climate. Yeah. Oops. I think I'm going the wrong way. Sorry. I thought, okay, so greenhouse effect. Why are we going back to greenhouse effect? Um, yeah, I don't know why. Oh, okay. Okay. I guess that was the end of oh man, I should have gone faster with the last video. Sorry, I didn't realize uh, I was almost done with this. All right, so actually, you know what I'm gonna do? I'm gonna do an example of um, a density. Yeah, let me do at least one example of density. All right, I gotta pause it and then I'll get to that. All right, so as I was saying, I want to, so that was the end of chapter 6. I want to end this with at least one density problem. Uh, I'll probably try to I'll do some more um, a little bit later on. All right, so anyhow, so density is this symbol. So this symbol right here kind of looks like a P. That's the symbol rho. It's the Greek letter rho. So rho is that's the universal symbol in science for density. It's the mass of something divided by the volume of that object. All right, and the volume. Let me go over the units first. So the units of mass, the typically will use grams, and then the volume will measure in cubic centimeters, centimeters to the third power. All right, so grams and centimeters to the third power, and there's a reason that we use grams and centimeters cubed because the density of liquid, not solid, liquid H2O, liquid water, fresh water, by the way. Water, that's supposed to be an A, sorry. Water. The density of fresh water, not salt water, which is a little bit more dense, the density of liquid fresh water is 1 gram per cubic centimeter. All right, so that's important to understand that because we'll often compare the density of things to the density of liquid water. And just to let you know, if we were to convert this to other units, sometimes you'll see this as well. For it's also 1,000. So this is the density of liquid water. It's 1,000 kilograms per cubic meter. So that's a cubic meter is a large amount of volume. Just to let you know, and then so a couple other things that I wanted to mention. 1 milliliter, right? If you've ever had any chemistry, you've dealt with milliliters before. 1 milliliter of liquid water is also 1 centimeter, 1 cubic centimeter. Right? And the other thing about that is in hospital settings, for some reason, they don't like to write it like this 1 centimeter to the third. They write it like this 1 cc. So in hospital settings, it's a cc, but that just means cubic centimeter. That's what the CC stands for, which is the same as this, which is the same as this. All right. So as long as you're dealing with liquid water. All right. So all right. Let's do a problem. So what we're gonna do, I'm gonna give you the mass of the Earth, which is 6 times 10 to the 24th. The radius of the Earth in kilograms. So we're gonna have to convert kilograms to centimeters, and then we'll figure out the density of the Earth, which turns out to be about 5.5 grams per cubic centimeter. All right. So I'm gonna show you that right now. All right, let me do this. All right, just keep in mind mass divided by volume. All right, so the mass of the Earth. All right, so the mass of the Earth is very typical. So this is the Earth, is 6 times 10 to the 24th. I'll write it like this: 6e24. All right, that's a 2. Sorry. And of course that's kilograms. Kilograms. Now a kilo of anything, a kilo just means times 10 to the third, right? So right away I know that there are 1,000 grams, 1,000 grams in 1 kilogram. All right. So the kilograms cancel. And so when you multiply by 1,000, all right, so let me get my mouse here. So when you multiply by 1,000, that's the same thing. Oh, I guess I should close this. That's the same thing as saying 10 to the third. So 10 to the third times 10 to the 24th, right? So this is 10 to the 24th. Let me write it out just to indicate this, just to make sure it's quite clear. So 6. So remember, this is just another way of writing this. 6 times 10 to the 24th times, instead of writing 1,000, I'm going to say 10 to the third grams. All right. So when you have the same base, when you have the exact same base and you're multiplying, all you do, of course, is just add. You just add the exponents, right? So that's really that's all you do. So this. Excuse me. All right. So this would be, of course, you just add the 24 and 3. So this would be 6. And now let me write it the other way. 6 times 10 to the 27th, right? 6e27 grams. All right, so this is what we're going to use, right? Remember the density, which we're going to calculate in just a moment, is the mass divided by the volume. All right, so now how do I figure out the volume? And now I haven't given you enough information to do that yet. So the radius of the Earth is roughly 6,400. Sorry, that's 2 zeros. Kilometers. So 6,400 kilometers. All right. Now I've got to change that to centimeters. All right. So that's actually pretty straightforward. In 1 kilometer, there are 10 to the third meters. All right. So that's pretty simple. So the kilometers cancel. And then in 1 meter, there are 10 to the second, or 100. That's just a different way of writing it. Centimeters. All right, so now the meters cancel. So 10 to the third, just like we did up here, right, where we just added the exponents. 10 to the third times 10 to the second is, of course, 10 to the fifth. So this becomes 6,400 times 10 to the fifth centimeters. Oops, that's a C. Centimeters. All right, and of course you could move the decimal place back 3 places, and then you could do it a much simpler way. 6.4, right? So if you move the decimal point back this way, 3 places, then I've got to add 3 more to this 5, right? And so that becomes times 10 to the 8th centimeters. All right, so here we go. So we have our 2 numbers. All right, so here, let me box this around. Let me box this in. All right, so we're going to use this. And the other thing that we have to know is the volume of a sphere. All right, so this comes from geometry. All right, or if you had calculus, you can actually figure this out using calculus. But anyhow, we'll just use the results. The volume of any sphere, that's an E, sorry, is always 4 times pi divided by 3 times the radius to the 3rd power. The radius to the 3rd power. All right, so now we're going to use that to figure out the volume. All right, so we're going to use this number right here to figure out the volume. All right, so this is going to be 4 pi over 3. That's just a constant times 6.4 times 10 to the 8th centimeters, but I have to raise that to the 3rd power. Notice I'm raising the centimeters to the 3rd power as well. All right, and then we're going to take 6 times 10 to the 27th divided by whatever this comes out to be. All right, so I'll get my calculator out here, and there it is. Let me move that a little bit. Oops, move it a little bit. All right, so here we go. All right, so I just want to show you this. Let me just show you this real quickly. So I'm going to go back to this part right here. So 6,400. All right. So if I say times 10 to the 5th, right? So that's going to be times. You got to do the way it works for your calculator. You got to do 1, and for this one there's an EXP button. 1 EXP to the 5th. All right, so I'll do that, and so there it is. So look, 1, 2, 3, 1, 2, 3, and then 2 more makes it times 10 to the 8th. So that's not written in scientific notation. All right. So anyhow, I've raised that to the 3rd power. Okay. So let's see. For this calculator, that's this x to the y button raised to the 3rd. All right. So that's going to be what this is to the 3rd power. That's 6.4 times 10 to the 8th to the 3rd power is that number. It's huge. Times 4 pi times 4 times pi. Where's pi? Let's see. Pi is right there, and then divided by divided by 3. All right, so this is going to be my volume. All right, so there's my volume. I'm going to put that in. Well, I don't have to put it in memory, but I'm just going to do that just for the heck of it. All right, so that's going to be in memory. Let's see. I think I hit that. All right, so that should be stored. All right, so now I take this number that I had. So I'm running out of time. I've got to make sure I do this. All right, so I'm going to take this number, 6 times 10 to the 27th, divided by this number, which is my volume, which I don't want to write out this entire thing. Yeah, it's really long. I should have put it in scientific notation, but anyhow, you'll get 1.09 times 10 to the, I think it's probably 27th or something like that. All right, anyhow, I'm going to take 6 times 10 to the 27th, right? So 6 EE to the 27th divided by what was in my calculator already, right? So I'm just going to say divided by memory recall. That's the way this thing works, right? And then that's my density. All right. So that's the density of the Earth. So it's 5.46, right? Which you round up, right? Here, so it rounds to 5.5. So the density of the Earth would be 5.5. All right. So that's I'm just showing you that there. All right.